Hello everyone, welcome to question 1D of the glucose question.
Yeah, I'm really starting to get tired now.
Yeah.
So many days, but maybe it's horrible.
Very, very heavy.
Okay.
The weird thing about this question is that in the previous questions it was always very, very to the point. I mean, okay, the first story about how this experiment was designed was very, full of words but not really with information. But this question is actually completely the other way around.
Yeah.
There is a lot of information and also a lot of things to think about. And I can understand when during your exam it can be a bit too much. So it's really, really good to dissect the piece of information.
Dissect.
Yes. Bob.
Yes. So
shall we talk first? Maybe tell about the question.
Oh yeah, sure. Do you want to read it this time?
I want to read it this time.
Yeah. My voice is.
A patient is considered to have hypoclemia when the glucose level is equal or below 750 milligrams per liter. This means that you have to bring the patient to the hospital. Suppose that bringing the patient to the hospital when the glucose level is 800 milligrams per liter is a total waste of time. How many repetitions should you perform in the analysis of glucose with this device to make sure that you bring the patient to the hospital for nothing in only 7.5% of the cases, and you leave the patient at home when in fact you should bring them to the hospital in only 1% of the cases? Between brackets we have used the precision calculating question 1A, 1B, 1 to question to answer this question. 10 points. So 10 points.
There's a lot of points. That means that it's like one full point on the exam grade. So if you have 180 minutes on the full 3-hour exam, you have 18 minutes to solve this question.
Yeah.
And there's not much to do, but there's a lot to think about here.
Mm-hmm.
So
we have two different numbers given in the question, 750 and 800, and two different percentages of wrong chances, let's say, of 7.5% and 1%.
Yeah, so we are looking at a question where we need to calculate the number of repetitions. So this is an experimental design thing, and this really smells like a question we can solve with G-Power, our favorite program.
Yeah.
So let's open G-Power.
Okay. For G-Power, when you open it, you might see things of alpha and beta. And because we have to define alpha and beta, we know that there's some kind of percentages in this question, 7.5% and 1%, but which one is which? We don't really know that, because before we have to do that, we need to formulate our hypotheses.
Yeah, there we go again, the typical weekly test exercise of formulating hypotheses. So you do this right now, and we will be back with you in about 1 second. You can just pause the video. Okay, now we are continuing.
We're back.
So let's see, Mimi. We have two statements that I see in this exercise. So I see, or exam question even.
Yeah.
I see
bringing a healthy patient to the hospital.
Yeah.
On only 7.5% of the cases.
Yeah.
And leaving a sick patient at home in 1% of the cases.
Yeah. So there's these two things. So bringing a healthy patient to the hospital.
Yeah, that's bad for the money.
Yeah, it's a waste of money.
I mean, okay, it's not nice because, I mean, there's already a lot of people with corona in the hospital. But, I mean, if the person is sick, it's really important. So bringing a healthy person to the hospital is a mistake, but it's not
as bad as losing a life because you left someone at home, whereas that person should have gone to the hospital.
That's something we really don't want, actually.
No, we really don't want someone to die at home.
So that means that thing that we really don't want,
we put in the alternative hypothesis, remember?
So that means that that leaving someone at home will be our alternative hypothesis.
Yeah, so now mathematically speaking, what do we, if we formulate the hypothesis, because I really always have a shitty problem with this. How do we write this down? We write down that? So
we say that we are comparing the level of glucose of someone, which is by the way 800 in the question, to a reference value of 750. And we have the question that it says when the glucose level is equal or below 750, it should go to the hospital. It is then a patient, a he or a she, or an it if you have other preferences. So that means that will be that you have to compare your mu1 with your mu0, so the reference value, and leaving the patient at home is when your mu, so of the patient that you're analyzing, is higher than the reference value.
Yeah.
So mu1 is larger than mu0 will be our alternative hypothesis.
I fully agree. I fully agree.
That means that our null hypothesis will be that we will bring the patient to the hospital so that mu1 is smaller or equal than mu0. In the case that you have a patient of 700 has level of 750, which means that he actually has to go to the hospital, it will be that your mu1 is actually equal or below mu0, thus bringing your patient to the hospital.
Yes, so now we can deduce a few things, because now we have thought thoroughly, I even do it on videos, thoroughly on about our hypotheses. Now we can look at G-power again, and we can start to fill in some things. So we're like clicking on this fake Word document G-power thingy, and then we have to decide a few things. We have to specify what type of test this is. Well, this is of course a comparison of a mean with a reference value.
Exactly.
It's a p-test. It's right tail because in our alternative hypothesis is
larger than the reference value, so we have a right tail test. Right tail, left, for you that way.
Indeed.
And then we have to put in our effect size, and the effect size we can actually calculate that one. So we click on the button determine, and it will pop up a screen next to it where you have to fill in some means.
So we have the mean of H0, so basically our reference value, which is 750, I think, right?
Yes, 750.
Okay.
That's the level of the hypoglycemia. And then we have the mean of H1 as our patient. Our patient had a value, a level of 800 milligrams per liter.
800.
And we need to use our standard deviation that we have already calculated in question 1A and 1B of 2 videos ago. That was 18.5848.
848, okay.
Yes, then we can calculate and we get an effect size of 2.6881720.
It should look here on my screen.
Of course, that value. And then we come to our alpha and our beta. So we haven't discussed that yet, which one is which. But let's go back into the lines of the text of a question. It says that you leave the patient at home when in fact you should bring him to the hospital in 1% of the cases. That means in 1% of the cases where you should bring the patient to the hospital, so H0 is true because we have determined H0 to say that we have to bring our patient to the hospital. When that is true, you actually perform H1. So that means that you get is that alpha or beta?
Alpha.
That's
so
alpha.
0.01 is alpha, I think.
Yeah, so that's when you accept H1, when the effect is that it's actually H0. So that means that our alpha is 0.01.
And this also means that our beta, so the odds of having the patient for nothing
in the hospital,
so he's healthy but we bring him to the hospital anyway, is 7.5%.
Exactly.
So that's beta, and then 1 minus beta, because that's of course what we need to fill in here, is going to be 1 minus 0.075.
Yes, so that means that we get a power of 0.925. And then we click calculate.
I clicked.
Okay, what we then see,
sample size is I think 5.
Yeah, sample size is 5. And the actual power is 0.932. That means that the chance that we actually have that patient in the hospital for nothing will be a little bit lower than the 7.5, but that's good. I mean, littler chance is only better.
Yeah.
So now you might think, well, this is weird because I formulated my hypothesis the other way around and I don't get 5. Well,
this means you probably got a 4 as answer.
Yes. If you did everything correct, but you only switch around the hypothesis, you would probably have gotten an answer of 4. And the reason this is, it's only also stated in the answering sheet, but we're gonna try to explain it to you, is that when you look at your H0 and your H1 of the in reject support and accept support, they're actually not exactly the same. And that's because you miss the level of 750. In the question, it's clearly stated that the glucose level needs to be below or equal to 750. But if you formulate it the other way around, your null hypothesis actually has the 750 itself. Okay, so the case is that once you don't have, when you switch around, the equal sign actually goes to the other hypothesis. And this is actually something that is not stated in the question. And normally that doesn't really make any difference, because when you switch around your H0 and your H1, you only talk about this exact value. But because it does in this case, you will actually test this patient one time too little if you do NS4. And for that reason, we need to do NS5, and only that one is correct. And if you don't understand this, look again at the answering sheet, look at the signs in the null and alternative hypothesis in the accept support testing, and then compare it with the question that actually only results in the other one, in the reject support testing.
Yeah, so basically we're now done with the entire question 1, which was a total of 25 points. So the whole question was ultimately about an ANOVA test to conclude whether the diet was effective. And in this, we basically in question A did the one checking one of the premises, which was whether the variances are homogeneous or not. And then in question B, we just calculated a confidence interval for the precision of the method, and then finally we did the actual ANOVA. And then in question D, we basically went a little bit on a sidetrack, and we would just try to limit the likelihoods in a certain case, so alpha and beta, and then calculate the number of repetitions that we would need to design such an experiment where alpha and beta were stated as was stated in the question. So this is just one of many possible answers, of course. So also, if you're puzzled about any of this, the precision of the measurements, so that's really lecture 5, where you can read more about that. Mm-hmm. Also the confidence interval of question B, so A and B is really something of lecture 5.
Then we have lecture 6.
Lecture 6 is ANOVA, of course, for question C, and then D is more of a question lecture 4 thing.
I think lecture 4, yeah.
Yeah, so that's a lecture 4 thing. So if you want more about that, look there.
Yeah. Okay, see you later.
Keep practicing.
Keep practicing. We'll try to upload as much as we can on the trial exam. Let us know if you have any questions that we can also make videos about and that we need to explain to you. And hopefully, you're gonna rock this exam. A question a day keeps the bad grade away.
Hey.